Voltage sources are usually analyzed in series with resistance in circuit theory. But the same electrical behavior can be represented using a current source instead. In this video, you'll learn source transformation and how it connects voltage and current source models into one unified concept. Source transformation is a circuit theory technique that allows a voltage source in series with a resistor to be replaced by an equivalent current source in parallel with the same resistor. From the perspective of any external load connected to the terminals, both representations behave exactly the same electrically. This concept is not an approximation, but an exact equivalence for linear circuits. It means that the terminal voltage-current relationship remains unchanged even though the internal arrangement of components is different. Engineers can therefore choose whichever representation makes the circuit easier to analyze. Source transformation is one of the most important bridging concepts in circuit theory because it directly connects Thevenin and Norton equivalents. It shows that these two models are not different systems, but simply two ways of representing the same electrical behavior. The mathematical relationship behind source transformation comes directly from Ohm's law. A voltage source V, in series with a resistance R, can be converted into a current source I, where I equals V divided by R. This current source is placed in parallel with the same resistor R. Conversely, a current source I, in parallel with a resistor R, can be converted back into a voltage source V by multiplying I by R. The resistor remains unchanged in value, but its position in the circuit changes depending on the representation used. These transformations ensure that the voltage and current seen at the output terminals remain identical in both forms. Because of this property, engineers can freely switch between models without affecting circuit behavior or analysis results. Source transformation works because circuit theory is based on terminal behavior rather than internal structure. What matters is how a circuit responds at its external connections, not how components are arranged internally. If two different circuit configurations produce the same voltage-current relationship at their terminals, they are considered electrically equivalent. This allows engineers to replace complex structures with simpler models without losing accuracy in analysis. This idea is fundamental in engineering because it shifts focus from physical complexity to functional behavior. It allows circuits to be simplified step by step while preserving all observable electrical characteristics. In practical circuit analysis, source transformation is used to simplify networks that contain combinations of voltage and current sources. By converting sources into a consistent form, engineers can reduce complex circuits into simpler equivalent structures. It is especially useful when dealing with mixed series and parallel networks. Repeated application of source transformation can reduce a large circuit into a single equivalent source and resistance, making calculations much faster and more intuitive. Simulation tools often perform these transformations internally, but engineers must understand the concept to interpret results correctly and verify circuit behavior during design and troubleshooting. In RF and analog systems, source transformation is a key tool for analyzing signal sources and impedance relationships. Many small signal models of transistors and amplifiers can be represented in either voltage or current form depending on the analysis approach. This flexibility is important in impedance matching, signal flow analysis, and amplifier design. Choosing the correct source representation can significantly simplify calculations and improve understanding of circuit behavior. Together with Thevenin and Norton theorems, source transformation forms a unified framework for equivalent circuit modeling, which is essential for both circuit theory and RF engineering applications. So, today, we learned that source transformation allows voltage sources and current sources to be converted into equivalent representations without changing terminal behavior. This concept connects Thevenin and Norton models and provides a powerful method for simplifying circuit analysis. In the next lesson, we'll explore capacitor fundamentals and begin studying how energy is stored in electric fields. If you found this useful, like the video, subscribe, and follow for the next lesson.